All right, so today's date, let's see, it is, oh, it's 12/1. Wow. I know, but I know my name, so I'm just going to put the date there. You're right. Yeah. You can do whatever you want, sure. I like the date so that way if you do watch my recordings, you know what day we did this, right? If you do, right? Yeah. So the topic today is going to be geometric, explicit, yes, explicit formulas.
You said forms, it's not formulas.
Well, formulas, there we go. So, what is a geometric sequence? Hopefully you know that it's a list of numbers in order, but then we're multiplying each time by the same number. So we're going to be multiply by same number each time, okay? Right? And so the one that's easiest to know is we know, let's like take 2, 4, 8, 16, 32, 64, ... Okay, that's probably the easiest one to start with because we know that we're just multiplying by 2. You guys agree? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and so forth and so on, okay? Now, the formula we want to use for a geometric one, for the explicit form, is A of n equals A1 times R to the n minus 1 power. Okay, and I'm going to highlight that. R stands for the multiplier. They call it a ratio. It's a real good question. So let's write that down. We know what A1 is, the first term, right? R is the multiplier. R is the multiplier. And the reason they call it R for ratio is sometimes we multiply by a fraction. I mean, not everything is going to get bigger and bigger and bigger and bigger by 2's. We might multiply something by a half. Half is big, right? But we don't talk about divide by 2, divide by 2. We say we're going to multiply by a half. So if I take a look at this exact, so if you take a look at this exact same formula here, and you just did instead 64, 32, 16, 8, ... It's just the opposite, except the difference is it's getting smaller. So we don't say, you listening? We don't say divide by because it's always going to be multiply, right? So how do you get from here to here? You multiply by 1/2. It's the same thing as divide by 2. Divide by 2, divide by 2, divide by 2 is the same thing as multiply by 1/2, right? So that's why they call it, because you asked a really good question. That's why they call it R for ratio, because we know ratio is a fraction. Or if we took a look at this one, we're really multiplying by 2 over 1, but we don't really need the 1. Agreed, right? We don't really need the 1. So we're multiplying by the same number each time. Okay? Yeah, Cody?
Why does the n turn into why does the n go above the r instead of below it?
Great question. So a long time ago we did the Skittles. Remember the Skittle things? And the Skeeters? Remember how the Skeeters kept getting bigger and bigger and bigger? And it was an exponential equation, right? And so one way we can do this, Cody, is this is 2 times 1, this is 2 times 2, this is, you ready? 2 times 2 times 2.
Yeah, so just...
This would be like 2 to the second power, 2 to the third power. You with me on that? 2 to the fourth power.
Yeah, no, I get that. But it just, instead of being below it, it goes above it now?
Right, because it becomes an exponent.
Okay.
Okay? And that is a little confusing because in one case, when you do the, now hear me out, when you do the recursive form, the n minus 1 represents what term? It is confusing. That's why you got to go do this for like a couple of weeks. The n minus 1 on the recursive, let me go over here, okay? If it's a subscript, it's talking about what term, right? But if it's up there, it's an exponent. It's different. An exponent means, take to that power. Really good observation, okay? So let's take a look at example 1. Here we go. So in example 1, there's 2 ways to do it. One is just keep making it and making it and making it until we get to the 10th. That will work, okay? If you can't figure out the formulas, you don't have a clue how to use them, just go, okay, well, multiply by -2. Just keep going, keep going, keep going, keep going, keep going until you make the 10th term. However, if we use our formula, we should be able to find the 10th term. So let's say we want to find A of 10, because that would be my 10th term, right? A of 10 would be my 10th term, okay? So let's use the formula. You watching? You writing this down? So my formula says take A1, which is 3. Now my multiplier, what am I doing from here to here to here?
Isn't it line by negative 2?
Now, if you have a hard time figuring out what R is, another little formula for finding R is always going to be, yeah, I'm sorry. If you take A2 divided by A1, you can always get R. If you have a hard time seeing what R is, take the second term and divide it by the first term. It always works. So what's negative 6 divided by 3? Negative 2, right? So I know that in this case, R is going to be negative 2. Right? If you take the second term divided by the first time, you'll always get your R. So I'll put my negative 2 in here. And then since I'm looking for the 10th term, I'm going to go 10 minus 1. Okay, now we're just going to need a calculator to figure that out, right? So to make it easy on my calculator, I'm just going to make that to the 9th, right? You guys agree with that? So we're just going to go, all right, I'm going to go 3 parentheses, I'm going to go negative 2 to the power of 9, 10 minus 1, right? Power 9, and there it is. So that's much faster than just making the term, okay? So my answer would be a 10 then is equal to negative 1,536, okay? That's what these formulas are so handy, right? Because they allow us to go straight to it instead of making the formula for it. Now, very rarely do people use the recursive formulas in the real world. But the recursive formulas, once again, tell us kind of what's going on, right? If you go to the recursive formula, and I put it on the board, here's the recursive formula. It says, hey, we're just taking, we're multiplying by R, right? But then, to get the 10th term, we just have to keep going, make it. But if we want to go fast and get to it quickly, we use the explicit formulas. Okay, so the explicit formulas are the ones that can go to it quickly, okay? All right. Number 2, make an explicit formula for this sequence. I didn't give you a sequence.
No, the 3.
Oh, there it is. Okay, thanks, Landon. For my 3, comma, negative 6, 12, negative 24. Okay, so we're going to go A of n. So when we need a formula,
Well, wouldn't we do A1 first?
yes, but we're going to make a formula. So when you make a formula, keep n as your variable, okay? So whenever you want to make a formula, keep n as your formula. So I'm going to go A of n, because I'm going to make a formula, is equal to, sure, okay? So if you're going to make a formula, we're going to use this formula, except we're going to put the numbers in, like 3, right? And our negative 2, we're going to keep n as a formula, okay? Tell me when you're ready, Nikolai. I'm happy to wait, okay? So if we're going to make a formula, I go to my general formula, okay, go to my general formula, and I plug in what I know. I know the first term, right? And I know my ratio. And I'm going to keep n as n because I need a formula, because I need a variable. So I'm going to go A of n equals 3 times negative 2 to the n minus 1 power. This formula will allow you to make any term in this series. This formula here works for this series. Okay, the formula we just made works for this series, okay? No matter what term you want, this will work for this series, okay?
As long as the term's different.
Right. So now let's go ahead and graph this, okay?
So that's the same.
So if we graph it, hopefully you guys already kind of know what it's going to look like. But this is going to look a little weird. Okay, so I'm going to kind of go like this. And I need, when I graph it, I'm going to need a negative part of this because it's going to go positive, negative, right? So I'm going to have my first term, second, my third term, fourth, fifth, okay? It's going to go, let's see, let's do a 10, a 20, a 30. I'll do a negative 10, negative 20, negative 30, okay? And my first term is 3, so I'll put a dot about there. I'll guesstimate 3, okay? First term is 3. My second term is negative 6, so I'll guesstimate negative 6 is about there. Third term is 12, so I'll put a dot about 12. Fourth term is negative 24, which would be about there. And we don't have a fifth term, but if we did, it's 48. Okay, 48 would be way up there. Okay.
Oh, so the
So it goes positive, negative, positive, negative, positive, negative, but it keeps getting bigger and bigger. So it just goes positive, negative, but it keeps getting bigger and bigger. So that works? Yeah, Cody?
How come we don't put lines on these?
Really good question. Okay, so if we put lines on them, we would have, because remember, a line, let me draw it. No, it's a really good question. So if we draw lines, Cody, check it out. Everything on the line is a point, correct? So that's saying we'd have a term right here.
Okay.
And there isn't, is there? There's a first term, there's a second term, but there's no such thing as a 1.5 term, is there, right? Okay, huh?
It looks
It
like
looks like a sideways problem.
Yeah, it does look really weird, doesn't it?
So, lines,
Okay. Now, is it a function?
no.
Yes.
Yeah, it's still a function. It still passes that vertical line test, right? Right? It still is a function, okay? But you don't draw on the line. I think we saw why you don't draw on the line, right? Okay, turn the page. Okay, here we go. Okay, Stellar Attraction Manager predicted that the weekly sales of their CDs would double each week, okay? The predicted sales for the next 10 weeks form a geometric sequence. The left two hand columns of Table 6 show the term number for this sequence and the term of it, okay? So what they're trying to do here is figure out what if they keep expanding, and I'm only going to do the next one, which would be 5, right? Which would be 5,000, right? No, I'm wrong. 8,000. I am wrong. Which is going to be my 4,000 times 2, which is originally my 500 times 2 times 2 times 2 times 2, which is 500 times 2 to the 4th. Now, let's make an explicit formula. Much easier, right? Let's just make our formula. So our formula, A of n equals A1R to the n minus 1. Okay, that's the formula we just got today. Okay, it's not a hard formula, but that's the one we got today. I'm going to highlight, okay. That's the main one we got today. And let's put in, if we're going to make a formula, keep n as a variable. Okay, we're going to keep n, so keep n as the variable. And let's put in what we know. Okay, so if we're going to make a formula, we're going to go, so we'll go A of n equals, what's A1? 500. What am I doing every time? What's my multiplier?
Do we not know, do we
2.
not know what n is?
We don't want to know what n is yet because we want a formula so we can.
do n minus 1.
No, we can.
Just leave it as n minus 1.
Yes. So we're going to go 2 to the n minus 1. So Nikolai, what we've done is we've made a formula for this sequence. Okay, so that we can say, okay, well, they want us to go all the way down to like the 10th. I don't want to go to the 10th. Heck no. But I could plug in now.
10 minus 1.
I can plug in 10 and know what the 10th one is, right? Man, I don't want to keep making this to the 10th one. That'd be a drag. You guys agree? So much easier to just say plug in 10.
So if we wanted to find if n was 10, then we put 10 minus 1.
10 minus 1 would be the 9th.
What do we do?
So then our calculator will go, you're right, we just go,
256,000.
we'd go 500 times 2 to the power of
11?
9. 10 minus 1 is 9, right?
Yeah,
To
but then
the,
you're finding the 9th and you're showing the 10th.
okay, now let me answer that question in a second, okay? Okay. Now, so nobody asked me this question, but why is it n minus 1?
Because you already have variable, you want minus the variable that it, like, minus 1 to get the variable before.
Okay, I like that. That's part of it. Ellie, you got another answer?
It's because you're taking the previous variable and then adding.
Right. So the first term is 500. It's already there, right? So the first term's already there. That's the first term. And then we start making terms from there. If you put in 1 for the first term, okay, listen, let's put 1 in here. What's 1 minus 1?
0.
What's anything to 0 power?
0. 1.
1.
My little cousin taught me
Yes.
that.
Anything to 0 power is 1, and 500 times 1 is 500. So the first term should make 500, you agree?
Yeah.
Because 1 minus 1 is 0, anything 0 power is 1, times 500 gives you 500, okay? All right, let's take a look at the rest of this, okay? So, create a 3-column spreadsheet. So, so to extend this to 10, what we're going to do is just do this, okay? So I know that A6 is, watch this, A6 equals, use my calculator. Can you see my calculator? I'm going to go and use my formula, okay? Let me erase what I have up here. Okay, I'm almost done. You guys got to watch. Now, I don't want to use their table. It's too much work. So check it out. I'm going to make the 6th term. I'm going to go 500 times 2 to the 6 minus 1, right? Which everybody knows that's 5, right? Agree? 5. Okay, so then A6 is 16,000, right? A7, I could use the formula. I can go 500 times 2 to the power of 6. Okay, guys, okay, 6 because it'd be 7 minus 1.
Yeah.
Right? Gives me a 32,000. Right? And then A7, I can go, okay, 500 times 2 to the power of 7 gives me the 8th term, right? So A8 is 64,000. And then A9, I can go 500 times 2.
28,000.
I was waiting for somebody to say that. Yep. To the power of 8. And then you guys are already realizing that, hey,
Wait, no.
that's the 9th term. Because I'm not subtracting 1. I'm not showing the subtract 1, right?
Okay.
Does that make sense? 128,000. And then I think Isaac said, Mr. Davies, why don't you just multiply by 2? Why are you doing that? Why don't you just take it and multiply by 2, right?
Yeah.
Yeah, exactly. That's what, 256,000, I think. A10, 256,000. Now, however, if we needed to go from here to here real quickly, the formula's faster, right? If I needed to go from here to here without anything behind, I'm just going to use formula, okay?
And what is this part called?
This is finding all. Yeah, no, this is just finding the terms. It's just all finding the terms. That's all. Okay. Now, a scatter plot. Well, scatter plot. I'm going to go, and I'm only going to do a few of these because it's going to come up here. Yeah, it's too big. 1, 2, 3, 4. Let's go first 5. First term, let's see, let's go 1,000, 2,000. I'm probably still going to be way off. 3,000. I know I'm going to be way off. I'm not going to get them all on here at all because it gets big fast, doesn't it? Right? 4,000, 5,000. So the first term was 500. Second term was 1,000. Third term is 2,000. 4,000, and of course, I like to ask Zoe. I always pick on poor Zoe because she always has the right answer. Is that arithmetic?
Yes.
Is that geometric?
Yes.
There you go. Is it arithmetic?
Arithmetic's the curve, right?
Arithmetic's gotta be straight, right?
Yeah.
Linear. So it's not arithmetic. It does curve like an exponential. So is it geometric? Yes, it's geometric. Okay. Find equation. See if we can get an equation, right? A of n equals A1 r to the n minus 1. Can you make a formula real quick? What do you think? Can you make a formula? I do. I want you to make a formula. Remember, if you're going to make a formula, keep n as a variable. Put A1 and put r in. You got it, okay? Okay, give it a try. Make a formula.
Wait, you need formula?
The formula fits this. The formula's going to fit these numbers, okay?
What is R?
R is the multiplier.
Yeah.
Yeah.
Isn't it?
It's back right up there, isn't it? That it right there? Yeah. So A of n equals 500. 2 times n minus 1. Okay. So we've got Ben. Don't do that. Got a little bit of work to do.
What?
Okay, just a little bit, and then don't call it homework because you have, oh my gosh, 40 minutes. Don't call it homework.
Makes no
We should just make this formula like some stuff.
Thank you, Zoe. Thank you. I get to do that.